Hello students, in this session
Let us solve a question on slope and deflection. A cantilever of length L and flexural rigidity EI stiffened by a spring of stiffness K is loaded by transverse load P as shown. The transverse deflection under the load is, we have to find that. The length of the is given L, this is L basically, and EI is the flexural rigidity. The stiffness of the spring is given as K and the load applied is P. P load is applied at the free end, and at the free end it is supported by this spring of stiffness K. And we have to find out the transverse deflection under this load, right? So what will be the transverse deflection? What will be the deflection under load? This P, right? So due to this there will be some deformation, right? But there will be also due the reaction from the spring also, so there will be less compression as compared to the without spring. So with this deflection we have to find out basically, right? So this deflection we have to find out, right? So options are there and we have to choose the correct options. So let us solve this question.
In this question we are given with a cantilever beam which is loaded with a load P at the free end, and one end is fixed and other end is free. Length is L and EI is the flexural rigidity of this beam. Now at the free end it is also stiffed with a spring of stiffness K, right? Spring constant K is given. We have to find out the total deflection at point B at the free end. What is the total deflection, right? So when this load P will be applied, there will be deformation in the bar, elastic curve will be obtained like this. So there will be deformation in the bar such that this is the deformation, suppose, in the bar, right? But when this spring will be compressed, it will resist the compression and it will develop a force to resist the compression, right? So a force will be developed opposite to this force, applied force, due to the compression of the spring. And suppose this force is F, which is equal to Kx. You know that spring force is given by Kx, the resisting force, right? So Kx, where x is the compression of the spring, which we have to find out, right? So x is the compression of the spring. So you will see that the condition is like this, that when it is compressed by some compression, it will be resisted by some force. So this P is the applied load and Kx is the force resisted by this spring, right? And what is now x is the deformation of the bar, this beam, right? This x is the deformation of the beam, which we have to basically find out, right? Deformation of the beam x at point B. We are saying this YB as well, YB. So we have to find out this YB, and now we are saying it x, right? Or you can say it is a x. This we have to find out. The deformation at point B, right? This we have to find out. So when the load P is applied, there will be deformation at the deflection at the free end, and due to that deflection the spring will be compressed, and this compression will be resisted by the spring it will be proportional to the deformation deflection, that is Kx. So Kx will be the upward force and P will be the downward force. So due to that total force there will be some deformation that is equal to the x, because x is the deformation, right? Which is equal to also the YB, because B point is compressed, B point is deflected, right? So now two forces are there. Actually the net force is there, net force, W net you can say. Net force is P minus F at the free end, right? One is the downward force which is applied, and Kx is the resisting force by the spring. So that is equal to P minus Kx. This is the net force, right, at the free end. So now you can assume that the free end is loaded with a force that is W net, and that is equal to P minus Kx. P minus Kx, this load, and due to this load, what is the deformation in the bar with beam? This we have to find out, right? So due to this W net P minus Kx, what is the deformation, deflection in the bar at the free end at point B? This we have to find out, right? This is now the new question. So we have for free end, we know the deformation formula, that delta is given by, which is now x. So delta or x is given by WL square upon 3 EI. Deformation is given by WL cube by 3 EI. So this is the deformation at the free end, right, for cantilever beam. For cantilever beam, right? This you should remember, WL cube upon 3I, right? So if it is WL cube upon 3I, put here W is the W net, which is P minus Kx. So x will be equal to P minus Kx multiplied by L cube by 3EI. So now x is here as well as here. So we have to find x only. So take x on left hand side. So you will get P is equal to P by PL cube by 3EI minus KXL cube by 3EI. We can take here on this side. So x will be equal to, you can take, so 1 plus KL cube by 3EI. So this will be equal to PL cube upon 3EI. Solve it and you will get x will be equal to, further you can solve it, that is 3EI plus KL cube by 3EI will be equal to PL cube by 3EI. 3EI to 3EI cancel. So from here you will get x. X will be equal to PL cube by 3EI plus KL cube. 3EI plus KL cube. So this is the answer of this question. This is the answer is the question. So this is option D. So option D is the answer. Option D is the answer. So we have utilized the concept of the deflection at the free end of a cantilever beam, and net force was the difference of these two forces, the load applied and the compressive force, and the resistance of the compression of the spring, that is F is equal to Kx. So this is how we can find out the deflection at the free end.